2011 Canadian Open Mathematics Challenge, Part B. Arthur is driving to David's house, intending to arrive at a certain time. If he drives at 60 kilometers per hour, he will arrive 5 minutes late. If he arrives at 90 kilometers an hour, he will arrive 5 minutes early. If he arrives at n kilometers per hour, he will arrive exactly on time. What is the value of n? Speed is equal to distance over time. That is a very famous equation we will use. But just want you to be careful here because they're mixing units. They're talking in terms of kilometers per hour, and then here they're talking in terms of minutes. So you got to make sure that your units match. So using this formula, 60 is equal to x, where x represents the distance. X represents the distance between, I guess, David and Arthur's house. Yeah. And then time, well, when it's 60 kilometers per hour, he's 5 minutes late. So if t is our time, meaning the time that it takes to arrive exactly on time, if it's 5 minutes late, then this should be plus 5 minutes. Now, be careful. It's not 5, it's 5 over 60, because this has to be converted to hours, because this is in hours. It's kilometers per hours over there. So we have to use kilometers per hours over on the right side. So this is our first equation. Second equation, the one where it's 90 kilometers per hour. Again, x is the distance, but this time it's t minus 5 minutes because he's arriving 5 minutes early. But don't put 5. Make sure you put 5 over 60. So there you go. Those are our two equations. We got two variables, x and t. We can therefore solve for x and t. And then in the end, we will need to figure out n, and n is equal to x over t, because that's when he arrives exactly on time. Okay, so this is some algebra now. From the first equation, we get, let's see here, 60t plus 5 is equal to x. And then the second equation, we get 90t minus 3 over 2 times 5 is equal to x. Okay, so they're both equal to x, so we can set them equal to each other. Let's do that. So 60t plus 5 is equal to 90t minus, what's that, 15 over 2? Yeah. So that means 30t is equal to 7.5 plus 5. And that's what, 12.5? Yeah. So 30t is equal to 12.5, and therefore t is equal to 12.5 over 30. And that is in that is in hours, because our time is in hours. But if I multiply top and bottom by 2, I get 25 over 60 hours. I'll just put an h in there for hours. And that's really 25 minutes. So there we go. T is 25 minutes. Now we can substitute that back into any of these equations to get the value for x. Let's just put it in there. So that means x is equal to 60 times t. But remember, keep the units consistent. So I got to put 25 over 60 because this time has to be written in terms of hours, plus 5. So that means x is equal to 25 plus 5, which is 30. And 30 is kilometers, just in case you're wondering. So I'll just put kilometers. Okay, so now we're at the final step, which is finding out n, x over t. So that's going to be 30 kilometers. And then t was 25 minutes, which is 25 over 60 hours. And then invert and multiply. We got 30 over 1, 60 over 25. And that is 72. 72 kilometers per hour is the speed that he drives at, which allows him to arrive exactly on time. 72 kilometers per hour. Integers a, b, c, and d and e satisfy the following properties. A is greater than or equal to 2, b is greater than a, c is greater than b, d is greater than c, e is greater than d, and 100 is greater than e. The greatest common divisor of A and E is 1, and A, B, C, D, and E form a geometric sequence. What is the value of C? All right, so let's tackle this question here. I'm assuming you guys know what is greatest common divisor. So if you don't, just review that, because that's a big part of the question. So we have A, B, C, D, and E. And they've told me that they form a geometric sequence. So that means that if this is A, this would be AR squared, AR to the power of 3, AR to the power of 4. That's a geometric sequence. Now, the key here is that they've given you this clue. And that's a very important clue. It helps us a lot, because if the greatest common divisor of A and E is 1, then that means that this ratio cannot be an integer. Because if it was, then the greatest common divisor of A and E would not be 1. And you can sort of fiddle around with numbers to be convinced of that. A and AR, which is essentially what E is, have to not have anything in common in terms of their prime numbers. So, like, for example, let's say A was 2 and E was 4. I mean, it's not going to be 4, but let's just say. And then I said, what's the greatest common divisor? Well, obviously, the greatest common divisor here is 2, and 2 is not 1. The only way the greatest common divisor could be 1 is if you had a scenario where you had no prime factor in common. So this one, if A was 2 and E was 3, then it would be 1. And the only way you can get that is if the ratio is not an integer. If it's an integer, then it always will just be a multiple. This number here will be a multiple of that number, and therefore the GCD would not be 1. So the conclusion I made from this very important clue is that R is not an integer. So if it's not an integer, I don't know what it is, but let's just say it's a fraction. Let's call it x over y. Okay, so with that, now this becomes ax over y, ax squared over y squared, ABCD up there, ax to the power of 3, y to the power of 3, ax to the power of 4, y to the power of 4. Okay? All right. So now we have to start thinking about this in terms of what we have discovered or concluded. Take a look at this one right here. That is now my E. And they told me that these are integers, A, B, C, and D. So that means this is right here is an integer. The only way that can be an integer is if A is divisible by y to the power of 4. And that is crucial, because otherwise it would never be an integer. So that means we can write A in terms of y to the power of 4, k times y to the power of 4. If it's divisible, then it's just a multiple of y to the power of 4. Or, for example, if it's 8, then y to the power of 4 could be, say, 4. We just have to ensure that we have some sort of a multiple. Okay, so now that leaves me to the conclusion that these guys are now written as follows. We have A, which is ky to the power of 4. We have kxy to the power of 3, right? You're just substituting this for each of those. The next one would be kx squared y squared. The next one would be kx to the power of 3 y, and the last one would be kx to the power of 4, if we substituted A as k times y to the power of 4. Okay, now I need a little bit of space. We are told that the greatest common divisor of A and E is 1. So here's A, here's E. So that means the greatest common divisor of ky to the 4th and kx to the 4th is 1. Now, that makes me conclude that k has to be equal to 1, because y and x are different, and therefore if k is 1, this will be satisfied. So now if we put k equals 1 back into there, we have y to the power of 4, x, y to the power of 3, x squared, y squared, x to the power of 3, y, and x to the power of 4. Okay, so this is my a, and this is my e. So I'll just put that in there, a and e. And then we had an inequality right up here that a and e have a boundary. So that means that a is greater than or equal to 2, and it's less than e, and e is less than 100. So we've got to come up with integers that fit that. We can only choose integers that satisfy this inequality. So for example, if we have concluded that a is y to the power of 4 and e is x to the power of 4, what integers can y and x be? There isn't that much of a choice, because once you choose a number greater than 3, it will be greater than 100 when you take it to the 4th power. So the only way this is going to work is if y is 2, this would be what, 16? Yeah. And then if x is 3, and then that would be 81. And that's the only possible way that this inequality can hold true. So therefore, my c, which is what I have to figure out, is this guy, x squared, y squared, is 2 squared times 3 squared, which is 4 times 9, which is 36. So that is the answer to this question. In the figure, BC is the diameter of the circle, where BC is the square root of 901. BD is 1 and DA is 16. If EC is x, what is the value of x? Okay, so I will need to expand this a little bit. And I'll draw one line connecting C to D, like that. And I think that should be it for now. Now, most of you know the rule that if you have a diameter of a circle, which is what BC represents, and you draw a triangle within that semicircle, that will create a right angle. So this is a right angle right there. And of course, therefore, that is a right angle. So those are two right angles. And let's label this now. BC is 901 square root right there. And then BD is 1. So this distance here is 1. So this is not drawn to scale for sure. And then what else? DA is 16. Okay, so from here to here is 16. And then I think that's it, right? Yeah. And then EC is X. Okay, so we can figure this out probably just using Pythagoras. So the first triangle, which is this one right here, that's a right triangle. So that means that BD squared plus CD squared is equal to root, BC squared, and then I'll fill in the numbers. BD is 1. CD, that I don't know. And then BC is root 901, all squared, squares. Okay, so this means that CD squared is what? 901 minus 1, which is 900. And therefore CD is 30. Okay, that's good. So just put that in there. And then I can use Pythagoras again to figure out on that triangle the value of AC. So Pythagoras on that triangle would be AD squared plus CD squared is equal to AC squared. So AD is 16, CD is 30, and AC, well, that's what we're trying to figure out. So this is what, 256 plus 900 is AC squared. And therefore, we have AC equal to 34. Yeah. Okay, so that means from there to there is 34. So if this is X, this A to E would be 34 minus X, correct? Yeah. Okay, so I think at this point we use Pythagoras again. And this time it would be on triangle AEB. Yeah, so First, I have to draw that in. Actually, I don't even have it drawn in. So let me draw it in first. I've got to connect E to B like that. Okay, so there we go. Now, this again, this triangle there is again a triangle within a semicircle. So that means that this is a right angle. And therefore, that is a right angle. Okay, so we again use Pythagoras, but this time on triangle AEB. Okay, so on that one, it would be 34 minus x squared plus BE squared. Okay. And that will equal the hypotenuse, which is 16 plus 1, which is 17 squared. Yeah. All right. And then I'll isolate for BE, and be 17 squared minus 34 minus x squared. Okay. Now, BE can also be used in another triangle, and that's this one right here. In that triangle, we can again use Pythagoras, which is triangle BEC. That would be that BE squared plus x squared is equal to 901 square root all squared. Yeah. So in this one, if we isolate for BE squared, we get 901 minus x squared. Oh, there we go. We got BE equal to that, BE equal to that, set them equal to each other. So 901 minus x squared is equal to 17 squared minus 34 minus x all squared. Okay, great. We got it down to one variable, so we should be able to solve this without any problem. Okay, so we got 901. And let me put the numbers on one side, and then put the x's on one side. X squared minus 34 minus x all squared. So 901 minus 17 squared is 612. And then this one I'll have to expand. So 34 squared minus 68 plus 68. So x squared minus x squared. Okay, so that works out pretty well, I think. So I've got, let's see here, 68x. The x squareds cancel, so then I've got this 612 plus 34 squared, which I believe is 1156. So that means we have 1768 divided by 68 is x, and therefore x is 26. And that's what they wanted. EC represents x, so therefore EC is 26. A group of N friends wrote a math contest consisting of 8 short answer problems, S1 through S8, and 4 full solution problems, F1 to F4. Each person in the group correctly solved exactly 11 of the 12 problems. We create an 8x4 table. Inside the square located in the ith row and jth column, we write down the number of people who correctly solved both problems, Si and the problem Fj. If the 32 entries in the table sum to 256, what is the value of n? Okay. Each student solves 11 problems, right? Each person solved 11 problems. So that means that that could have been either 8 of the S's plus 3 of the F's, or it could be 7 of the S's plus 4 of the F's. Both of these scenarios are indicating 11 problems being solved. So this group, I will say X students solved 11 problems that way. And this group, I'll say Y students solved 11 problems that way. Now the table sum, that's the one that we have been given as 256. That basically represents, according to my variables, 8, which is this one, times 3, which is that one, times x, which is the number of students that have solved 11 problems correctly in that format. And then we have to add to that this 7, this 4, multiply it and then this y. And that is basically how the table would behave in terms of mathematics if you put it into an equation. So that means that 256 is equal to 24x plus 28y. And what we have to do is find integer solutions to this. We are only given one equation, so we have to, we can't solve mathematically. We just have to plug in numbers and see. Because x and y represent integers. They represent the number of students. So we have to find integer solutions to this equation. Before I do, I can divide through by 4, and that would reduce it to 6x plus 7y. Okay, so we got x and y, and let's see here. Now, the number of students, well, it could be 0, I guess, for x. And then when you do, we have to get integer values. And you don't get any integer values for y for x equals 0, x equals 1, x equals 2, x equals 3, 4, 5, but you do for 6. When x equals 6, you get y is equal to 4. And this is the integer solution. So that basically means that this x up here is 6 students, and this y up here is 4 students. So what are they asking for in this question? The value of n, which is what? A group of n friends. So how many friends are there in total? Well, the total number of friends is x plus y, which would be 6 plus 4, which is 10. 10 is the answer to this question.